So this is Battle of the Circuit Breakers. I'm here in Berlin for the second time in 2 weeks, but probably you don't know me because I was there for a conference called BobConf. Who knows about Bob Conference? One guy, yeah. I held a Clojure workshop that was super fun since I just learned Clojure recently. So I'm Nicolas Frankel. I've been doing consulting for like 17 years in the Java Spring, more Spring than Java ecosystem. I've been a developer, I've been a technical lead, I've been an architect, solution. Well, I've done basically what the customer wanted me to be. I mean, you know that consulting is just above slavery. And 6 months ago, I decided, I had enough of that. I prefer to be paid to go to speak to conference and have beer with the people. That would be very nice. And actually, I found a company that paid me to do that. And because my company is a cloud provider, I really invested a lot of time into like cloud stuff. And I mean, I already was interested into DevOps, but how you can like mix DevOps with the cloud. My company is called Exascale. We are a cloud provider. We are a European cloud provider. Who here is using the cloud? Yeah, nearly everyone, or at least the people who are not asleep. And who here knows about the Cloud Act? Cloud Act, it's a US law. Okay, yeah, now you know, but basically, if you are using the cloud, you should know about the Cloud Act. It's a US law that tells that if you contract with an American company, it means that they have access to your data wherever the data center is located in the world. So if you are a German company or like a privacy-minded company located elsewhere, you should be very wary about that. We are not a US company. All our data centers are in Europe, so yeah. And I know the guys, the people who do the support, they are working just beside me, so I know how good they are. So this talk is about the circuit breaker pattern. So first, I will have some general introduction about microservices. Then I will introduce the problem. Then I will talk about the circuit breaker pattern. And I will provide you with 2 ways to implement circuit breaker, one with Istio and one with Hystrix. I will also have a demo, and then we'll conclude that the answer to most problems in life is it depends. So this is the microservice definition that you can find. I think this one is on Martin's folder. Definition about microservices. So you make components, smart endpoints and dump pipes, decentralize everything. You automate a lot of stuff because, it's necessary, it's required, because then you have a lot of components. You cannot just do it manually. Design for failure. This is very important for the rest. Not design upfront like we did some years before, where an architect just designed the stuff and then everything had to follow the plan. We make continuous improvements. Organized around business capabilities and product, not project. Who here does microservices? Okay, about half the room. But some hands are like half-half. Yeah, that's good, that you know where I'm heading to. So in general, that I've never seen in real life. You have microservices that are more or less designed around business capabilities. In general, they are more designed around departments. They are designed around organizations. Whether the department is like handling a dedicated business capability, it depends. And of course, we don't do product, we do project, because that's the only way we know how to spend budget is through a project with a project manager. So products, again, never seen them. Perhaps you work in an organization that makes it possible to do that, and then in that case, please stay there, because it's really good. And I love that stuff, like you must be this tool to do microservices. The problem that most people think about the technical aspects, like, you must have automation, you must have monitoring, DevOps all the way along. The problem is, yes, you must have all that, But the real issue is organization. Why do you think you should do microservices? A wrong answer would be because everyone does it. So why do there are some people who wave their hands when I asked if they did microservice? So what is the reason for that in your organization? It's not because it's you, you are not guilty of that. What is the reason? Yeah, it's a talk where I ask questions. It's, you cannot sleep or work on your computer or on your phone. Sorry for that.
You told us so.
I told you what? To bring your computer? I told you, no, it's not true. Not me.
I already started.
So why are you doing microservices?
Abstraction, maintainability, scalability.
Okay, so among that, scalability, yes, because you can spin up as many instances as you want. You can do that with a monolith as well, to be honest. Nothing prevents you to do that. Sorry? Yeah. Yeah. Ownership. Can you go into details?
I mean, if you have 10 teams maintaining monolith, then you have 100 commits a week.
Yeah. I think that's a very good answer. In my opinion, I would tell it in another way. You are doing microservices because development team doesn't scale. Because at some point, your development team is too big, and as you mentioned, you have too many commits, you have too many branches, or you have too many feature flags, it doesn't scale. So in my opinion, from what I've seen, what I heard, what I've read, the only reason why you should do microservices is an organizational reason. It's not a technical reason. So if you as an architect or as a lead architect or if you come from a technical point of view and say, we are doing microservices, it won't work. And, well, this is a nice picture of me, but the most important guy in the picture is the other guy. And perhaps you have heard about Conway's Law. This is him. I had to take a picture with him. It was at Go to Berlin. He was there. Yeah, you were there too. Yeah. And actually, well, yeah, I mean, everybody knows this quote of him. Like, your architecture, your technical architecture will basically map one-on-one your organization. And so, what they tell you to do is, yeah, it's easy. You reverse Conway's Law. So basically, you create the stupidzas team, and you will have microservices architecture, right? That's what you read everywhere. Like, it's easy, just do that. And that's what Netflix does. Everybody knows that Netflix does it. Netflix does it very well. They do microservices. So they have those, like, product team using microservices, and inside one team, they have a product manager, they have a UX expert, they have developers, they have DevOps, they have QA, they have everything. They are autonomous. So that's how you do it, right? Right? No, that's how you do it. And this is a traditional legacy organization. Difference cannot highlight it more. And yeah, this is just for fun. But the biggest problem with that is that at the top of each of those silos, what do you have? A middle manager. And here, what do you have? Nobody, because you are self-organizing. So in an old organization, you have managers, middle managers, And in this new microservices organization, you make them obsolete. So, I told you that the only reason to change to a microservice architecture is organization. And basically, you are making the process of migrating to a microservice organization the responsibility of people who will be made obsolete after the change. Do you think it will work between us? Not that much. Yeah. And of course, if you don't know how to do a monolith correctly, then how can you do microservices correctly? So, for the rest of this talk, I would stop using, well, I won't stop, but I should, because it will escape my mouth. You should use the word web service, because even if you don't do microservices, you probably do web service. And that is perfectly fine. You can use web service all you want. Microservices, not that much. Okay, so that is my introduction, is probably stop using the word microservices because it makes it look cool. It's not cool at all. It doesn't work, at least unless you have a new organization or an organization that is able to renew itself, which is not really the case in general. Okay. And now we've got this very scientific law that says that if something can go wrong, it will go wrong. And we will apply it to web service architecture or just a web service call. Because, as I told you, I was an architect at some point in my life, so I'm very good at UML diagrams. And UML diagrams on dashboard, they are super, super easy. Like you have this box with this swim line. No, it's not called a swim line. It's lifeline. Thank you very much. Yeah. I'm just being removed my architect title. So you have this lifeline, and what happened is just you make a call from A to B, and everything is fine because it's on the dashboard. Nothing bad happened. Great. And notice that it can be an API call, like from a Java call, calling one method from another method, or it can be network dependent by a web service. It's abstraction. Everything is fine. And of course, I attended the talk in this room this morning, and the guy reminded us about the fallacies of distributed computing. And they are fallacies because basically every time we fall into the trap of forgetting this is not true. And the first one is the network is reliable. Of course, the network is not reliable. An API call is reliable. Network call is not reliable. So by just migrating, let's move to web service architecture, it will make things much better. No. It will make things much harder, and sometimes, at some point, perhaps you will get some benefits. Isn't that true? No? Yeah. And, oh shit, I have microservice in the title. I didn't change it. And now I just noticed it. Sorry for that. So let's imagine I have a backend service, and I have a front-end service, and I have two clients that call the front-end service. And it's fine. The call is made. It goes there. Perfect. That's life like it should be. And at some point, for any reason, the backend node stops working because it's not reliable. And clients will still make requests, and they will get piled up in F at some point. And what happens? Now F is down. And now if you have a web service architecture of different nodes calling each other, great, you have just propagated the failure of one node into your whole architecture. So you say, I will switch everything off. I will just save the requests, and when you switch it on again, then the request they just flood the first service, and it's just bad again. So you need something to handle that stuff. And that's fine, because people, they know about it. They have talked a lot about it since some time. It's called the circuit breaker. So basically, the circuit breaker is just you introduce something in front of between F and B, and if something bad happens repeatedly over time, you just say, oh, I just opened the circuit, and then you fail fast. And that is very important. You want to fail fast. You want to fail fast by having tests, but you also want to fail fast at runtime if something bad happens in your architecture. And the circuit breaker can be managed as a state machine. So basically, you start, then everything is fine, the circuit is closed, you make your calls. At some point, it fails, but it might happen. Once in a while, it's okay, it fails, shit happens. But if actually the backend node is down, then you must do something. You must stop the error from propagating all over your architecture, and so you open the circuit. And now you fail fast every time. F doesn't call B anymore, it just say, oh, I know what happens, it's bad, let's get back, and it fails. And after a condition that can be time, that can be a number of errors, it can be anything at all, then you tentatively try to close it again. And in that case, you watch it very, very carefully. If it succeeds again, then you close it completely again, and you are back to square one. And if it doesn't work, then you open it again, and perhaps you wait a bit more time next time until you try that to half close it again. Make sense to you? It's a pretty good strategy. And you have a lot of fun options to consider. Perhaps you can think about, hey, how many calls should I fail before I open the circuit breaker? And afterwards, how long should I wait between two tentative to close it again? Should it be fixed? Should I double it every time or anything? And if it works again, how many successful calls should I wait until I consider it's back in the closed state again? I mean, you can think about a lot of configuration options. You are engineers. The problem is not that. The problem is, what do you do if it fails? What should you do if it fails? What do you think? What should you do if the call fails? Scream. Yeah, scream is okay. So on your pager, you Sorry? Back off and retry. Yeah, that's basically the stuff. What else? What's the fallback strategy? Okay. You are all wrong. No. The only answer is it depends. I told you I was a consultant. The answer is it depends. There is no real good answer to that. And to illustrate my talk, I've been working in e-commerce for some time, and I think it's really an interesting area. And I will use the e-commerce web shop as an example. So in this example web shop, I have different services that each of them have a different scope. I have a recommendation web service. You know, this stuff that, hey, people who bought this also bought that, and like Amazon does that a lot. They try to upsell you a lot of stuff that probably you don't need, but hey, it's so cool. You've got a pricing web service. So you've got something that, hey, the customer wants this product, how much does it cost? Of course, you have a payment web service. It might be yours, it might be someone else. And you have a logging web service because, yeah, you want to have centralized logging, so let's put everything in one place. And the answer to what you should do depends a lot on these kind of services. If logging fails, shit happens. Doesn't prevent you from selling. So the typical stuff is, yeah, you return, you fail fast, you try again after some time, the fallback is just send a 500 and everything is fine. Recommendation. And now we start getting into the real meat. What should you do if the recommendation engine fail or service fail? Again, it depends. What does the business want? Actually, this is not critical to deliver. This is not critical to make your shopping experience work. This is just an added bonus that you want to upsell. And that's fine. So you could say, okay, we just display no recommendation at all. That works as fine as before. Or you could just say, okay, this is still important. We just cache the previous recommendations and display them. That's not very important, that's just optional. Or you could also say, okay, we always have a static set of recommendations, so in case the service fails, then we always show those items because they are pretty popular and we have a lot of stocks and whatever. Pricing. Pricing is a bit harder because actually you need the price. You cannot say, I won't do without any price. So in that case, the general recommendation is to cache the price before. That means that you must have designed your calling service to cache the result it got before. That means you cannot say, hey, I forgot about it, just had it, and it works out of the box. You must design it. Because the problem is not to have outdated data in that case. It's better to sell at the wrong price than not sell at all. I mean, I'm an engineer, I don't like that, but business people, they want to sell at every cost possible. So in that case, you would have a really big push from the business to sell at any cost. We lose money, that's not a problem. We make up in margin and it's fine. Payment. Again, this is required. You cannot just do without any payment. But now the question becomes, do you accept to temporarily store the credit card data somewhere? Encrypted, of course not, because you will need to pass them again. This is like a compliance problem, or not? And again, it goes a bit further than, hey, just return a 500 and everything will be fine. Failing fast is not an option. Failing fast is good to stop the propagation of the errors, but the fallback is, again, the most important thing. And in that case, you need to think it through with the business, because they might have a very definitive view on things. And so basically, you have two big strategies. Either you have the black box, so I don't know what happens inside. I fail fast, everything is fine because the fallback is pretty stupid. Or I must know what happens inside. And in that case, I must design the fallback strategy before in accordance with the business and the compliance and, a lot of people. And in the first case, you can have really dumb stuff. You can have a service mesh, you can have a proxy, you can have anything you want in between. It will return 500, everything is fine. In the second case, you need to put something that knows how to handle the failure, that knows it very well. And so you have this thing, service mesh, that handles all the stuff that were previously meant to be handled by libraries, but I will try to show you that's not as easy as it seems. And of course, if you are using Kubernetes, Istio is the main service mesh right now. It's super hot. It's open source. It implements the sidecar pattern, so every time you can schedule a pod, then it can bring you a new pod that does whatever it wants. And in general, it does it to set up the network with an Envoy proxy. And from a bird's eye view, every time you call something from outside your pods, then you must go through this Envoy proxy. And every time you receive a call from outside your pod, you go through a proxy. So you can control everything that goes in and out of your pods. So the sidecar pattern means that every time you schedule something automatically without declaring it explicitly, then you have this Envoy proxy deployed as a pod next to each other. And you can check for secret breaker configuration in Istio. I mean, it's just a few lines of YAML. It's very, very easy to do. You say how many times should you fail before opening the circuit. That's what we talked about earlier. We must check, I mean, what's the sliding window? Because free errors mean what? Over 2 hours, 3 hours? No, but like there is a sliding window of 10 seconds. How long should we wait before trying to close the circuit again? And this one is interesting because now we are like looking at the stuff from an infrastructure point of view. And in infrastructure, probably you don't have one node for the whole service. You probably have a cluster of nodes because you want to handle failure. And in that case, Istio knows about your infrastructure, so you can have a limit. Even if bad stuff happens, that means that you still want to keep at least a few nodes in the pool. You cannot have like no nodes at all in the pool because something will be definitely wrong. So you imply that the node is bad, but the service itself is not bad. And the problem, the biggest problem is that you have no fallback. You don't know how to handle that. So you can use it as an afterthought, but it won't manage the recommendations or the pricing or the payment. And on the other side of the spectrum, there is the white box approach saying, hey, I will handle everything by myself. And there is this like library by Netflix called Hystrix. And basically, it's in maintenance mode, like Anna told me before. Thank you, Anya. So, yeah, but now it has been superseded by something called resilience for J. So if you go on Hystrix homepage, they will tell you we are in maintenance mode. We don't do any. We only do bug fixes. We won't make any new version. Go use resilience for G. The problem that I see so far is first, like for example, I will show you about the Hystrix dashboard. They don't have the dashboard, which is super sad, especially for demo purposes. And it's not integrated into Spring Cloud, for example, which I like a lot. So not that great.
Sorry, maybe it's in progress.
Okay, yeah. So now it has been integrated into Spring Cloud. So perhaps next time you will see this, this presentation, I will change my demo. I hope so. Thank you very much. And basically, the basics of Hystrix is, well, you can do a lot of stuff, but you wrap your code into such called Hystrix commands, and then you run them asynchronously from a thread pool. And because Hystrix does a lot of metrics, then you can have like the circuit breaker implementation because it will measure the success, the failures, how many times did it fail in a sliding window, and blah, blah, blah. And the most important stuff is it lets you add a fallback logic. Whatever logic you want, you can do it. And the problem of Hystrix is, yeah, you have a lot of configuration options, and probably it would be hard to get them right the first time. So probably what you need to do is to have like guess them, like deploy it and see how good or how bad it works because you are really a lot of power. And because it's white box, you are inside the nodes, so you have not the big picture. So you don't know when you call a service how many nodes there are. or if they are all down, or half of them are down, or only one of them is down, and it's just bad luck. And right now, Spring Cloud, Netflix, makes it very, very easy to integrate Hystrix, and also you have like integration with all like other libraries from Netflix. And I've talked too much, I need to do a demo. So here I have a shop application and I have a pricing service. So I will show you the pricing service. I love Kotlin, so I've did that in Kotlin. That's fine with you. I mean, if you don't understand the code, it's not that hard. I mean, even if you are a die-hard Java developer, it's quite easy to understand. I've used reactive programming, not because I like it, but because it's just because I can. And so this pricing handler, like, just will receive like requests, and it will try to quote. So it will get the product ID. And how do I compute the price? Well, I just like have a super very complicated formula. I transform it to a byte, so it's instead in a very small range. Then I will just put it positive. I will jitter it a bit, so I won't have high variations, and I will just return it. I mean, it's just stupid formula, but it works. Also, what I did is I introduced myself some failure in it. So basically, what it will do is, after some time, it will start failing a lot. So I have a timeout grace count. So it will be stable for some calls, for a number of calls. And afterwards, it will fail like 4 times out of 5, just for fun. No, it's not fun. Yeah, you shouldn't do that. It's just because, hey, it's good to be a presenter and not doing real work. And here I have this like fetch quote service. So this is a client of my application, and it gets the get quote. This is the method that will be used. And so basically I use the quote URL. And here you notice that what I will do is, once I get the response, I will cache it, like very sophisticated caching, a mutable map. So you shouldn't do that at home as well, but again, for demo purpose, it's super good. And let's try that. So the first thing to do is to try the pricing service. So I'm not using Quarkus, but it starts very fast. And here I will start my shop. It's less fast. And we can see what it does. So basically I can it's pretty stupid, huh? So you see the price is changing a bit, but not that much. And because I'm really, really super lazy, I have like a script for that. So I will just constantly ping the shop service. So this will be my client, and the shop service will ask for a quote from the quote service, and then I will hopefully get my response. So here I'm still having the grace timeout count, so I still got very good prices coming from the service, and now, because I've baked in the cache, Now I start receiving stuff from the cache. And now, normally, I will get the service again at some point. So I'm not that bad. And you can see it on the Hystrix monitor. So here you can see, whoops. Here you can see the 2 requests I've made manually, and here you can see the scripts that starts doing its stuff. And so basically I don't have that many successes, and I have every time I have a timeout, I don't get the right response. And here it's because, as I told you, it puts stuff in a queue, and at some point the queue is full and the stuff gets rejected. But here, because of my configuration, the circuit breaker is still closed, because my configuration makes it not that easy to open it. So I'm considered to be good enough right now. So what I can do is can start another client, because the point is like to make it really hard on the poor service. I love this dashboard. So now the queue is really overflowing. I don't have like 1 or 2 rejection. I have a lot of rejections. Sometimes I've got a success, and sometimes I get into timeout. But still, I'm more or less able to get it right. Let's add 1 more client. And now the poor service starts to get really stressed. And you see here it opens right now. And because of that, the pressure gets much lower. Like it says, OK, now I return everything right now. I don't wait for anything. I just return everything right now. And then, of course, because this number of clients, they don't move because nothing moves, then you will get these like lines over and over, and it will be pretty boring at some point. But here you can see here that those were short-circuited. That didn't happen with just one or 2 clients. So right now, my circuit breaker implementation is actually used, and it makes it so that the failures that come from the code service, which was very badly written, I must admit, then they don't propagate all over my architecture. The Hystrix dashboard is really good. So I will stop that because, yeah, it's not that interesting once you've understood the stuff. So, this concludes my talk. In conclusion, don't do microservices unless you really, really know what you're doing. Do it for the good reason. It's perfectly fine to do web services. Probably you need to do them anyway. Just don't call them microservices just to look cool on your resume. Doesn't work. If you do that, you must handle the failure, because failure will happen. It's just not if, it's when. And for that, for handling failure, you should implement the circuit breaker. You should think beforehand of the implementation that you want to choose, because it depends on the typology of the service that you are requesting. If it's logging, not so important. You can fail fast with Istio, not an issue. If it's a pricing, might be very important. So think about it, and in that case, you must use Hystrix or Residence4G or whatever rocks your boat. Just use something where basically you can wire in business logic. So thanks for your attention. You can read my blog. You can follow me on Twitter. You can find the source of everything I demoed so far on GitHub. And you can read the full-fledged article of this talk on my blog's company. And now I have some time for some questions, if you want. Like 4 minutes. And if you don't have any questions, because I'm basically just standing between you and more beer, I can understand that. But that's a bit awkward if you don't ask any questions at all. So one question would be good enough, would be made my day. Oh, thank you very much. You saved my life today.
Yeah, first, thank you for the session. It was very informing. What is your opinion on the current state of Hystrix? Because you said it's in maintenance mode?
Yeah, so basically, right now, you shouldn't use it anymore unless you have very good reasons to do so. One of the reasons is you make a gap analysis between Resilience 4G and Hystrix, and you say this feature is not yet in the Resilience 4G, just I need Hystrix. So that would be my best answer.
Thanks.
Thanks. More questions? Or it's beer time? Beer o'clock. Oh, thanks.
So where we should put Hystrix? Is it like on edge services, or it should be
No,
on the
no,
whole
it's
system?
okay. I was not clear enough. Basically, sorry if I was not clear enough. Here, I have the pricing service, right? So this is in my schema, the backend, which it is not really backend, but anyway. And the shop is the front end. And you see that the shop basically will be calling the pricing. And so this is where you put Hystrix. So here, this is the main method. And because of those like nice Hystrix annotations from Spring Cloud, then if something like doesn't work, it will call this method, which will call it from the cache. So again, that point is very important. You must put it in your caller code because at this point, you want to handle the fallback. With Istio, you cannot do it because you do it from outside. It's black box approach.
But let's say that the chain of services. Like
Yes?
Service calling service, calling service, calling service. Should I put it in each step of the chain, or it just on the edge?
It depends. It depends, really. You must think about each like node in the chain to see what fallback you do want. Again, you must reason about the typology. Hey, I don't care, then that's fine. I just put Istio as an afterthought, it's good.
I'm asking you because I think in the Hystrix documentation was information to put it only on the edge, to not use it internally.
It depends.
Okay.
Really. You might have different fallbacks, because in general, you might have a chain, perhaps not a very long chain, but depending on the client, on the purpose of the client and the purpose of the node you want to call, you might want to do different things with different configuration. And if you just put it on the edge and let everything in your architecture fail until the last point, you will be like a fireman who don't know where to look. I hope it won't happen to you, but I would really think very strongly about putting it wherever it's important and making the same reasoning for every like caller like pair. Other questions? Yes. Gentlemen.
So this is like mostly the synchronous examples. Are there any valid cases in async setup?
Yeah, with Hystrix, you can have sync or async, because I'm not super at ease with async. I'm not a reactive kind of guy. I just use this. But you can do the same with async command. So there is a string command and an Hystrix async command.
How does it make sense in the async context?
I'm not sure I understand the questions. How does it make?
In async, you're like, it's almost like fire and forget. And then what are you really doing with the circuit breaker? Because
Okay, if it's fire and forget, I prefer to use the word fire and forget than async. In that case, if it's fire and forget, in that case, it's logging. And logging, if you don't log, it's not that important. So don't use a circuit breaker in Hystrix. Use it in Istio. Just configure it for whatever works for you. It will be fine. Okay, guys, thank you very much. It's beer o'clock, and I'm still available for a nice chat. Thank you very much.